Welcome to IT Pro TV. I'm your host, Don.
Coming at you live from San Francisco, California.
You're watching IT Pro TV.
Hello, welcome to another exciting episode here at IT Pro TV. I'm your host, Mike Roderick, and today we're doing our CompTIA A+ 901. And in this episode, we're actually picking back up. This is a part 3, so if you missed part 1 or 2, make sure you go back and watch those first. But this is part 3, and we kind of left you with a cliffhanger at the end of part 2. We talked about a lot of the different components that we find on a motherboard. Now we want to talk about the different sizes of these motherboards or their form factors. And here to clue us in is Mr. Wes Bryan. Welcome back, Wes.
Hey, Mike, thanks for having me back. That's right. And he cut me off in that last episode, right? And you're going to see why here, because we've really saved some more of the technical details for the end of this episode. Or I should say mini-series that we're working on here. We've talked about the various components, like Mike said, that you can find within the motherboard. We really just wanted to establish what is this thing and what is it doing for us. And that is going to be definitely very important information that you have to know on the A+ exam, but there's also going to be some stuff that is more like push-ups or sit-ups, and anybody can look at me and can tell I don't like sit-ups. And it is some more of the, the stuff that you really just have to, grab the mental handle and just hold on for, because remember, one of the last things we said in that last part there, we said, specification standards, if you will, are, they promote interoperability. You don't have to get vendor locked, right? You have choices as a consumer, and that's a great thing to have, to be able to say, it's not, I know what this component is, now I just have to figure out who do I like as a manufacturer? Who do I feel as the consumer makes a better product? But there are some things that the standards that we're going to talk about when it comes to motherboards that you're really going to have to know for the exam. All right, so let's go ahead. I've got a little diagram here, and let's start with some of these standards, all right? Now, when we talk about standards, you might notice, if you've looked at the 901 objectives, they call out size, all right? Now, I'm going to tell you honestly, I'm a little bit cautious with that term size. I think it would be better, like we've talked about, Mike and I already, form factor, right? Form factor isn't just about the size of a motherboard. It's a lot of things about the motherboard. Size is definitely one of those things, but form factor also denotes the characteristics of a motherboard. How are the components? What's unique about this board? And again, if you're following a form factor, there's a standard that you have. Now, with these form factors, I do want you to understand, in any PC build, in any computer build, there are 3 form factors have to match. There's no way around it. The case itself, right? The motherboard and the power supply. Those are 3 form factors that all typically fall under a single standard. So for instance, I'll have an ATX case, tower if you will. I'll have an ATX motherboard, and I'll have an ATX power supply. Those 3 things absolutely have to match when you're building your next computer, or when you're maybe replacing a component, right? Mike comes in and says, and I know you could do this by yourself, Mike, but Mike says, hey, Wes, I need a new power supply. Well, the first thing you'll have to do as an A+ technician is say, all right, Mike, what standard do you have, right? Well, Mike probably knows. I know Mike knows, but maybe your consumers don't know what the standard is, and that's up to you to make that determination. So let's go ahead and let's talk about the one that has been around for a very long time and pretty much cornered the market as really the just most widely adopted motherboard form factor there is, and that's known as the ATX. Now, when I say it's been around for a long time, Intel came out with this form factor in 1995. Wow. It was the replacement for the earlier AT. Now, I'm going to mention just briefly, you don't have to know these for the A+ exam, but I've always thought as an instructor, it's good to know where we've come from and where we've progressed to maybe, see a little bit about the future. And I tell you what, if I knew all of that, I would be winning the lottery. But the very first PC form factor that came out was called IBM PC. It was probably as big as a 50-inch screen TV. Not really, but the next one that came out was known as the XT. Now, the one that stood the test of time for a little bit was called the AT. It was called Advanced Technology. All right, now, when we progressed up, that one actually came out and stood the test of time up until 1995. And in 1995, they came out with the Advanced Technology Extended. It was the one that replaced the earlier AT boards. Now, with the AT boards, I want you to make sure that you jot these down and commit them to memory for your A+ exam. It's not the fun stuff, but it will help you pass this certification exam. ATX is a 12-inch by 9.6-inch motherboard, all right? And this is why you could probably start to see case is important, right? Because if I have an ATX case, it has notches in that case where I can align the ATX motherboard to it, and then I can screw the ATX board to the side of the case when you're making or building your PC. Now, I will tell you, as just a brief side note, a lot of these cases today have multiple positioning points, you know, just in case, making it a little bit more versatile, right? But you still have to know it must support at least the ATX standard, regardless of what other standards it has, if you have an ATX board, because the mounting points are consistent with the dimensions of the board itself. And the other thing I want you to know here is one of the things that the ATX board brought is a major, I guess, divergence from the earlier input standards that we had. In the AT boards, in those days, in fact, if we can take a look here at this motherboard right here that I have, all right, in the earlier AT boards, you had a single keyboard connector, and that was called an AT DIN. It was an AT DIN connector. In fact, we still use it today. It's used in audio communications now. It's not used in input devices for keyboards, right? And if you had a mouse in that day, you had a serial mouse, right? And you would plug it in this way. Well, that wasn't really convenient. So what the ATX standard brought in is the PS2 port. Now, I know what your gamers are thinking out there. Sorry, guys and gals out there. We're not talking about the PlayStation 2. What we're talking about is Personal System 2. All right? This replaced the earlier, what would be known as the AT DIN connector, which was a 5-pin DIN connector. DIN just stands for the German Institute of Standards. It's just the German DIN, the German rendition of that or whatever. This is called a 6-pin mini DIN. And you can see this is for keyboard and mouse. Now, I will tell you that the colors, they don't really mean anything. In fact, sometimes today, like for instance, I got a newer board and it actually blends these two together. So keep in mind the color codes are really just for us to know. And it became kind of more of a de facto than it did really you know, a standard to color code them just so you know which one's keyboard and which one's mouse. That's one of the big things that I want you to know when it comes to the ATX standard. Now, the other thing that the ATX standard did is it would rearrange, from the earlier AT days, it would rearrange the CPU and rotate the whole board 90 degrees to put that CPU, if you ever looked inside your case, the CPU is sitting right under the power supply. And that's because the fan of the power supply can help assist the overall cooling system within the machine itself. Now, there's some other great things that it did. In the earlier AT standard, right, we had what were known as a P8 and a P9 power connector, and there was a problem, well, could be a problem with these, right? They were identical. So how do you arrange it, right? You had to know that black and red together is how you would arrange these, and you could reverse them. And think about reversing the polarity, or your power supply could cause all kinds of problems, short circuits or damage, right? So they said, you know what? We can't have that anymore. Let's make it a little bit more convenient for the PC technician to look right away at a power connector and know how to install it within the machine. All right, so let me go ahead and show you. One of the other things that the ATX standard brought in is this 20-pin connector. And I know it's kind of hard to see, but Mike, can you see that little notch right there?
I can.
Right? And then you can see these keys, right? These specific shapes. They call it a notched keyed connector. And what that would know, we would know exactly how to put the clip from the power supply, because it would have the notch on it, and then the clip, the power supply connector actually matches the notches that are in this 20-pin connector. So I want you to know that. Now, the ATX standard has gone through many revisions because in the earlier days we didn't need a lot of power in our computing, not as much as we need today with multi-core processing and a lot of other things that are going on, expansion slots that we'll talk about coming up here. So it has gone through its revisions, but we have a power supply where we'll definitely talk about some of these revisions, and we want you to know. But that's the big thing that I want you to know is that the ATX brought the 20-pin connector. All right, now, that is one of the major things. And while we're still here with these motherboards, the other thing I want you to want to tell you is in the earlier days, if you wanted some of the functionality that we could get with all these devices that we see here, you had to get an expansion card. Like we've talked about expansion cards, and if I wanted maybe another serial port in those days, you can get a card that was probably 15 inches long and you would install it into a slot on the motherboard. Well, When the ATX standard came out, what they did is they integrated the I/O interface into the motherboard itself.
Now, Wes, you've got 3 motherboards there, all of which have these integrated components back there, and we're saying it's a standard, yet they don't really look like they follow a standard. Am I missing something here?
Well, you know, that's kind of interesting here. What the ATX standard, let me show you guys here. What the ATX standard calls out is a rectangular pattern, right? The dimensions of a rectangle, essentially. And if I put these 2 different boards up here side by side, you'll notice that they're almost the same width, right? Length and height, if you will. And that is because the ATX standard integrates these components in and calls out the rectangular pattern, right? The dimensions of that rectangle. But what it doesn't call out is what you can put within the rectangle. So what it does is it gives the manufacturers flexibility, not saying that, hey, you have to have a certain amount of ports here, these ports here, just that we're going to have a rectangular pattern, and you can decide if you want to have these ports here, maybe not even include some of those ports. So it still gives you a standardization. And Mike, you and I were talking about this before we even started this part 3 here, about when you look in the back of your case, you see that little rectangular pattern, and if you're building your case computer for the first time, it's got a blanking plate, right? A blanking plate is just a cover that you're going to pull out. And one of the great things is if you have an ATX standard, those blanking plates and that hollow frame there, they're all going to match. And when you insert the motherboard in the case, the rectangular pattern will match up, but it's probably going to be the fact that you're going to have different ports, if you will, because the manufacturers, it's up to them how they arrange them.
Very cool.
All right, so those are, that's some of the things, and let me see if I've missed anything here on that. Again, the IOs, you know, they're integrated in the motherboard. That was one of the major things. Now, I've also talked about the fact, if we could go back to the diagram here, we've got several different motherboard form factors, right? The next one you're going to see is the micro ATX. Guys and gals, let me not confuse you here. This isn't the only ATX standard. There are many different revisions, but these are the only 2 primary ones that you need to know for the A+ exam. Now, the micro ATX, everything's the same. Everything as far as the arrangement, all of those specifications that I told you, except for the dimensions of the board. And that's one of the great things. When you're studying for this exam, if you can remember you know, one little set of specifications and it applies to more than one thing, you're going to save yourself some time and memorization when it comes to the, you know, what you need to know for the exam. So the micro ATX, it would come out 2 years later, 1997, and it's a 9x6, actually 9x6, yeah, let me get this right. 9.6 inches by 9.6 inches. I'm having a hard time with English there. If we look, I've actually got a micro. Actually, no, this isn't a micro ATX. I take that back. This is an ITX board. We'll get into that one here in a second. But it's a square board. This is the mini ITX. That'll come up next. It was a 9.6 inch by 9.6 inch board, right? The power supplies are the same. I will tell you, one of the micro ATX specifications is a maximum of 4 expansion slots. That's really the only difference, is that it's because of its size. They said, well, we'll give you a maximum defined in the standard of 4 expansion slots. So keep in mind that they're great for very small form factor devices, like for instance, if you're doing a home theater PC, right? Yeah, they're great for that. We've had somebody else that I know that took and turned one into a firewall, but again, they have a limited expandability because, again, they're smaller devices. But for the most part, the only thing that changes is the dimensions and really that limiting factor, the 4 expansion slots. Now, on our diagram here, we've got a couple more, and I probably could have put ITX first, and I just want you to know that the ITX standard, it's the basis for ITX. You're not going to go out there and find an ITX board. All right, it forms the basis for all the other ITX standards, right? It's never formally released to the market until we came up with mini ITX, right? There's mini ITX, there's nano ITX, Pico, and even mobile today. And mobile ITX is like a credit card size board, so you could just see smaller boards, right? Well, the mini ITX board, it came out in 2001. And that's the one that we have over here that I kind of confused with the micro ATX. The mini ITX is 6.7 inches by 6.7 inches, right? The original design did a passive cooling system, which means they were completely fanless. And why is that? Because they were primarily developed to have low-powered, low-heat CPUs in them. And that's still the fact today, but with with CPUs getting a lot more stronger, we could still do a kind of a passive cooling where you might have just a heat sink, and you could even see fans in them today. Typically, with these, you only see a single expansion slot. A lot of times what you're going to see is that the I/O functionality, the input-output, will be integrated directly in the motherboard itself. Let me show you what I mean here. You'll see that compared to our more full-size board, you have 4 RAM slots here. Notice that this one only has 2. That's a commonality here, all right, in these mini ITX boards. And you can see the square pattern here. You can see that we have our IOs, and again, interestingly enough, guess what? The ITX mini ITX standard follows the ATX standard, right? So for the most part, the ITX standard isn't too far off the ATX standard, but the big thing here is it was for low-powered CPUs, right? In those home theater PC type builds, very, very small footprint, right? Something that could fit in almost what you would say is like a top set box for your cable company, right? So very, very handy. That is another one that we want you to be aware of, right? So those are some of the form factors when it comes to the motherboards themselves. Remember, 3 form factors that must match anytime you're going to build a machine. It's going to be your case, right? It's going to be your motherboard, and it's going to be the power supply as well.
All right, Wes, great stuff there. Just a wealth of knowledge when it comes to the components we're going to find in our PC. We've been focusing in on the motherboard, the integrated components, the non-integrated components, and we kind of rounded things up in this episode talking about the motherboard themselves and the form factors and the standards that we need to be aware of when we're building a PC, repairing a PC, as well as passing that A+ 901 exam. So we thank you for that, Wes. Any parting words for our viewers?
Well, I do have a few other things I want to talk about. I do have something that they call out, and this is kind of interesting. We've been talking about expansion slots the whole entire time, but one of the things that we haven't defined are those expansion slot specifications as well. So that is something that we kind of got to cover here because you have to know, right? When we talk about expansion slots, as you've seen, as Mike and I have talked, they're all different shapes and sizes, right? So how do we know what one does what, right? And that's why I want to take just a few more minutes here just to talk about these expansion slots as we round up. And unfortunately, we don't get out of specifications and standards quite that easy.
I tried.
So he tried to save you a little bit of pain here. But we do have to talk a little bit about these expansion slots, right? So on the exam, they call out a series of these, right? And we've actually got these, I've got a little diagram up here, so if we can kind of look at that. We have PCI, oh, and look at this. We just got a whole slew of alphabet soup here, right? Well, the expansion slot has what's known. Remember we talked about bus, right? Well, that's a bus architecture, right? The expansion slot sits on those traces, and that bus architecture is going to be important because, remember we said interoperability. It's interoperability if you're following the same standard, if you're, so it is important to understand these standards. Now, the first one we have right here is called the peripheral component interconnect, and this one's been around for a very long time. It's almost considered legacy today. We still see it. We still could potentially use it. And this was developed back in 1992 by Intel, and then later they handed this over to what was known as PCI SIG. That's a special interest group that basically oversees the PCI standard. All right. This is a 32-bit bus, or it could be 64-bit bus, which means 32 bits wide going into the CPU. I want you to remember that each one of these 32-bit buses, again, you could have 2 32-bit buses on a single board, and each one of those buses could have 5 cards. So you can get a total, believe it or not, maximum the standard supports is you can have 10 PCI cards. If your board supported it, you can expand out to 10 cards, right, maximum. And I want you to remember the bits, right? It's the width of those traces, right, that pathway that we talked about that goes into the CPU, it's 32 bits, right? Overall, it's really 64 bits, but there's kind of like a dividing line, if you will, between the two 32 bits, and each card, or each of the 5 cards sits on its own 32-bit bus. Now, there were some limiting factors to this. It was what's known as a parallel interface, and a parallel interface is one where we have multiple adjacent copper conductors, and the problem with that is you get what's known as crosstalk and electrical interference. Think about if I'm sending an electrical signal down one of those conductors and it kind of bleeds over, it interferes with the highway, if you will, that's next to it, right? So there was only so much power you could put over a PCI interface before it would cause crosstalk and interference. So it was a little bit limiting. I want you to remember some other specifics. All right, standard configuration was 33 megahertz, right? A hertz, if you will, is one clock cycle, if you will, and we measured in how many clock cycles per second. So 33 clock cycles per second, if you will. And again, I know a lot of standards guys, but you can do this. The total speed was 133 megabytes. Now that being said, remember I talked about the PCI Special Interest Group? PCI Special Interest Group said, you know what, this parallel interface, we're having kind of a problem with it because it is a shared bus topology. And what that means is all of those 10 cards were communicating across the same path.
So to use a term you talked about in one of our previous episodes, it starts becoming your bottleneck.
It certainly does. It uses what's known as bus mastering, right? Because think about maybe a call that I'm on, right? If I'm dialing between, Mike and I are talking, rather than butt into the conversation, right? Only between our two phones, people can't really butt into that call, right? And just interrupt that call, right? So what these cards would do is use bus mastering. Since they're all using the same highway, I got 10 cards, who's going to talk? Well, they would use bus mastering, and bus mastering just means that this card would say, hey, I got to talk. Everybody else, you got to be quiet, right? So again, limiting, right? One card talks, everybody stops. The other card talks, everybody stops. So I also want you to know bus mastering is the way that they would communicate. So PCI SIG, the Special Interest Group, said, oh, that's not even efficient. We need all cards running at all times to get better performance. And later on, they would come up with another interface that we're going to talk about in a second. So what they tried to do is between coming up with a new technology, PCI they could see was coming to the end of its efficiency. So they said, hey, you know what? How about we take the dividing line out of those 32 bits, those two 32-bit highways, and we put them together, one 64-bit, and we stick a single slot across that entire 64-bit platform or trace, right? That would be what was known as PCI X. PCI Extended. All right, that's really all I want you to know about PCI Extended. It wasn't highly adopted. It was really expensive. It was seen in server technologies, and it essentially says, let's take the dividing line out of those two separate 32-bit buses, we'll slam them together with all 64 bits, and we'll put a card across the top of it, and we'll increase the speeds up to about 266 megabits per second, right? Again, very expensive, only commonly seen inside of your server environments. But even that was still using the parallel interface. So what they did is they came out with the next generation interface, which is really what we're using today, and that's PCIe. PCIe is the Peripheral Component Interconnect Express, and it uses a serial interface, and the serial interface is essentially a set of sequential information that's going back and forth across that bus. And one of the great things is it eliminates some of that crosstalk, if you will, and when we put a lot more voltage, all we're doing is increasing the communication across that single interface. So it's a serial interface, and it's a full point-to-point communication. Now, there are some of the PCIe standards that I want to just briefly talk about because it's gone through some different revisions, all right? PCI 1, all right? PCIe 1, version 1, and let me just stop here for a second and let me say one other thing. One of the great things about PCIe is now not only can you have a single interface, a single path, they made it to where they can actually stagger and add individual sequential communication. So even though it's not a parallel interface, you've essentially said, I've got one pipeline, now I'm going to add another pipeline, and eventually all the way up to 16 of these, right? You might hear them called lanes, right? So you'll have one lane cards, which is exactly like it sounds, just a single lane in and out across the motherboard. You might have a 4-lane card, which is 4 of those lanes wide, 8 all the way up to 16.
All right, Wes, so really what we need to know is the speed of a single lane, and then we can just multiply that out.
Makes it so much easier, doesn't it? But that's
Yeah.
absolutely the truth. You know, keep in mind, like we've said, you know, you have a single serial lane, and it's just great that they allow you to, you know, in the design that they attach multiple lanes, easiest way. So let's look at, there's really 3 PCIe standards that you have to know, and just make it easy. Version 1, version 2, and version 3. And let's kind of run through the speeds that you can see on the different lanes. And really, when it comes down the exam, remember what Mike said. You know, that's going to make it easier for you, because if you can remember the single lanes, you don't have to remember 4, 5, 6 different standards, right? So for instance, we have PCIe 1.0. Single lane transfer speed is 250 megabytes per second, right? So that means if I have a 4-lane card, multiply it times 4, right? We got a gigabit. If I have an 8-lane card, well, we have 2 gigabytes, and not gigabits, gigabytes per second. And then if I have finally the 16-lane, right, that's going to be 250 megabytes times 16, right? That gives me 4 gigabyte transfer speeds, right? So fairly easy once you know that single lane speed. Now, when we move into 2.0, everything, the single lane speeds double. And that's another thing that might make it easier for the studying standpoint, right? 250 on the 1.0. We get into 2.0, the single lane speed is going to be 500 megabytes. And then it's a multiplier after that, right? We have 2 gigabyte transfer speeds for a 4-lane. We have 4 gigabytes for the 8-lane. And then the 16-lane is pretty impressive, brings it all the way up to 8 gigabytes, right? 8 gigabytes for those point-to-point serial-based connections. Then we also have 3.0 too. And 3.0 has been more of the common standard. Mike and I were talking about this because we're geeks, right? They got a 4 in draft right now. And as of 2017, it should be released fairly soon. But I want you to know the 3.0, right? Single lane speed, 4 gigabytes. Now, it's a little off than that, right? It's 3.94, but you don't have to worry about that. And all the references that I've seen, if you're not getting really, really specific on it, no 4 gigabytes for the single lane. Multiply that. Oh, and you know what? Well, let me back up. It's actually a gigabyte, right? Because I said everyone's a double, and I'm going to get my math wrong here, right? Again, the single lane speed is a gigabyte, all right? And then that means the 4-lane is going to be 4 gigabytes. Imagine what the 8-lane is going to be. 8 gigabytes, right? And then the 16-lane is going to be 16 gigabytes, right? So let me just recap the single lane speeds for you guys one more time so you guys can figure out the other multipliers, right? Version 1.0, we got 250 megabyte transfer speeds. Version 2.0, it doubles, 500 megabyte transfer speeds. Version 3.0, it doubles yet again. We've got a gigabyte when it comes to a single lane transfer speed.
I like that. That makes it easy, and I can do that math, and we can figure out if we've got 4 or 8, as long as I know that single lane speed. Now, Wes, are there any other PCI standards we need to be familiar with?
You know, there's one more that they call out. It's kind of simplistic because it follows the same standard. It's called Mini PCI. Mini PCI is what you would see inside a laptop. So as far as the standard goes, just know the PCI standards that we've already talked about. However, there were 3 different type cards, and these were really about the connectors themselves. The standard's the same, so that's a great thing. You don't have to worry about it being different than PCI altogether, but we're talking about it's the same as the original PCI. They have a Type 1 card, which had a 100-pin connector in it. A Type 2 connector, or a Type 2 card, which, good thing here, also had a 100-pin connector. And then they had a Type 3 that had slightly different connector, and that was a 124-pin connector. And again, Mini PCI, as far as the standard goes, just a smaller form factor that would be shoved inside of a laptop because of the fact that we don't have a lot of space within it.
All right, Wes, so I'm going to have to ask the obvious question. Type 1, 100 pins. Type 2, 100 pins. There has to be a difference, though, right?
There really is. What it came down to is how the manufacturers, what the manufacturers implemented them for. The most common one was really the Type 2, and this would add network functionality to a laptop that didn't have it. So you'd put one of those Type 2 cards in there, 100-pin card, and you'd have like this little X jack that would pop out, and you could put a modem, like one of the old RJ11 jacks, or as we progressed, you could actually add Ethernet capabilities, which we'll talk about those PCI connections, or excuse me, the Ethernet connections in another episode. The last one, Type 3, which is interesting, I've never actually seen one, and it was one that was actually used for a hard drive. But for whatever reason, I've actually never never seen one of the Type 3 cards. So Type 2 was definitely one of the ones that were more common until its successor would come out, which we'll also talk about later, known as the Express card.
All right, Wes, just a ton of information there. In this particular episode, a lot of information about the standards and what we need to know to pass the exam. But over the last 3 episodes, we've covered all the different components on that motherboard that we need to be familiar with. So we thank you for that, Wes. Appreciate it. Any parting words for our viewers?
No, just pay attention to your standards. There's a reason we have them, and as an A+ technician, it's going to be up to you to know what those standards are.
All right, well, you heard it here, folks. Hope you enjoyed watching this one. Signing off for IT Pro TV, I've been your host, Mike Roderick.
And I'm Wes Bryant.
And we'll see you next time.
Thank you for watching IT Pro TV.